Trigonometric functions are functions which are like sine theta, cosine theta, tangent theta, cotangent, secant and cosec theta. So these are 6 trigonometric functions, and you get at least 3 to 4 questions in every SAT level 2 mathematics 2 paper which are based on either trigonometric functions or inverse trigonometric functions. Now, a basic definitions of all these functions, sine theta, cosine theta, tangent theta, secant theta, cosec theta and cotangent theta is basically based on the triangle and a right angle triangle as a matter of fact. So if you have a right angle triangle which is, let's say, ABC, BC is hypotenuse, AB and AC are known as the legs. So suppose let's take this as C, let's take this as B, let's take this as A. Then according to the Pythagoras theorem, your A square will be equal to B square plus C square. Now in this case, sine theta, or let's take this angle to be theta. Now sine theta is defined as B by A. So sine theta will be equal to B divided by A. What will be cos theta? Now cos theta will be equal to C divided by A. C divided by A. Now you can always recall these values because this theta is this. So adjacent side is C, and therefore cos theta is adjacent divided by hypotenuse. Sin theta is, the side which is opposite to this angle. So opposite divided by hypotenuse. That is sin theta. Once you find out sin theta and cos theta, other trigonometric functions, that is other 4 trigonometric functions are basically related with this only. For example, tan theta is basically sin theta divided by cos theta. So if you divide sin theta and cos theta, your answer will be B by C. Similarly, other angles, for example, secant theta. What is secant theta? Secant theta is 1 by cos theta. So 1 by cos theta means A by C. What about cosec theta? Cosec theta is 1 over sin theta. And once you know that it's 1 over sin theta, your answer will be A by B. And finally, cotangent theta is basically 1 over tangent theta, which is equal to C by B. So what is important? Important is to find these 2 functions, these 2 trigonometric functions, sin theta and cosine theta. Once you get these 2 functions, other functions will follow, with the help of these things, that the very definition of tan thetas and other things. So that's one. Now, that's when we are talking about a right angle triangle. Now, there are various properties of these trigonometric functions, various angles, and something like if you want to calculate, let's say 2 sin theta plus 3 cos theta, okay, and the value of theta is, let's take pi by 3. Pi by 3 is basically 60 degree. So in radians, it's pi by 3, in degrees, it's 60 degree. So if I want to find the value of this function or this expression for theta is equal to pi by 3, my answer will be 2 sine pi by 3 plus 3 cosine pi by 3. Now, these are some important values like 0, 30 degree, 45 degree, 60 degree and 90 degree, for which you should know the values of sine, cosine and other angles, other trigonometric functions especially. Now, sine pi by 3 is basically sine 60, and the value of sine 60 is root 3 by 2. And what about cosine pi by 3? Cosine pi by 3 is again cosine 60 degree, and the value will be 1 by 2. So the expression this 2 sin theta plus 3 cos theta at a particular point theta is equal to pi by 3 will be 2 into root 3 by 2 plus 3 into half. So that will give you 2 you can cancel, and then it will be root 3 plus 3 by 2. Another important aspect of trigonometric functions is the graph of those trigonometric functions. So rather than taking all the graphs of these functions, let's take only 2, which are sin theta and cosine theta. Now, what will be the graph of sin theta? So if you have let us draw the graph of some important trigonometric functions, especially sin theta. So the graph of sin theta will be something like this. Where this point is 0, this pi by 2, pi, 3 pi by 2, 2 pi, and this side also is negative pi, negative 2 pi, and here the value is 1 and this is negative 1. Therefore, you can see that the sine theta is confined to negative 1 to 1. So, the range of sine function is negative 1 to 1, and whereas domain is entire real line. Similarly, if you draw the graph of cosine theta, it will look like this. So from a distance you can say that both are same type of graph, but here the point is 0, this one is pi by 2, and this is actually 3 pi by 2, and likewise this is negative pi by 2, negative 3 pi by 2, and so on and so forth. Here also this is 1 and this one is negative 1. So again cos theta is also between negative 1 to 1, as a range of cos theta is negative 1 to 1, and the domain is entire real line. Now one more graph, that is of tan theta. Now tan theta is basically sin theta divided by cosine theta. Now therefore, whenever cos theta is 0, that will be an asymptote of tangent theta. So cos theta is 0 at pi by 2, negative pi by 2, and so on and so forth. So that's a convention to draw asymptotes as a dotted line. So let's take this also like this, and 3 pi by 2 also, and negative 3 pi by 2 also. Then the graph of tan theta will be something like this. So this is tan theta, and as you can see that the asymptotes are wherever cos theta is 0. So this point is 0, this is pi by 2, this is negative pi by 2, and likewise 3 pi by 2 and negative 3 pi by 2. So with the help of these graphs, sine, cosine, tangent and cotangent, etc., one can see the behavior of these trigonometric functions. Wherever they are increasing, decreasing, the value is becoming positive, negative, and so on and so forth. Again, tan theta graph is actually range is negative infinity to infinity, entire real line, and the domain is all real values except those values where cos theta is 0.